In other words, now when we look at preparation of hydrogen chloride gas in water, the question is, how can hydrogen chloride gas be converted to hydrochloric acid? Hmm? Hydrogen chloride gas can be converted to hydrochloric acid by simply dissolving it in what? In water. And when you dissolve it in water, you must use an inverted funnel. Hmm? You must use an inverted funnel. The inverted funnel is this one that I'm talking about, such that the acid falls down in the water through an inverted funnel. You see, inverted funnel, this funnel is supposed to be facing up, but now I've made it to face down. So that's what we mean by making the funnel inverted. So the solution of the gas in water forms hydrochloric acid. That one we have already agreed. When the gas is bubbled through water until no more of the gas can dissolve, the product is concentrated hydrochloric acid and contains 36% by mass of hydrogen chloride. So when dissolving, the apparatus should be arranged as shown below, and the method is only suitable if the gas is very soluble. So hydrogen chloride gas is also very soluble in water, like ammonia, so it should never be collected over water if you want to prepare the gas. So this is the apparatus. But what is very important here is you must use an inverted funnel. So this is our flask. It contains sodium chloride and concentrated sulfuric acid. So we are having concentrated sulfuric acid coming in from the thistle funnel. And when concentrated sulfuric acid reacts with sodium chloride, we are saying hydrogen gas is produced, which is read through this delivery tube, and it is added to water, or it is dropped into water using an inverted funnel. So the procedure is here. The rim of the funnel must be just at the surface of water in the beaker, and this avoids water sucking back into the preparation flask. So the reason why we use an inverted funnel is very important on this part. We use an inverted funnel to stop water, because now you see it is difficult for water to go upwards. Whenever it tries to go upwards, it will be made to fall back. So we don't want water going back through this funnel and the delivery tube and going back to the flask, because we are using concentrated sulfuric acid, which reacts badly and vigorously with water. So we use an inverted funnel to stop water to avoid water being sucked into the preparation apparatus. To avoid water being, pressure can pull this water back into the flask. So that's the reason why we use an inverted funnel. A delivery tube cannot be used because it would suck up water into the preparation apparatus. We cannot use this delivery tube, or we cannot let this delivery tube come and fall into the water, because it will suck or it will pull the water back into the preparation flask. Take note of that. I repeat, this is very important. When we are preparing a solution of hydrogen chloride gas, which is hydrochloric acid, the hydrogen gas prepared is added to water using an inverted funnel. And we use an inverted funnel, not a delivery tube, to stop or to avoid the water from being sucked back or from being pulled back to the reaction flask. Since we are heating, you remember the other part of preparation of ammonia also, I think you remember. Whenever we are heating, we always try to avoid the water from falling back into the preparation flask. So when we were preparing ammonia, you remember we had to make sure that the flask is slanting, still to avoid the water from sucking back into the preparation flask. So here, the way to stop water from falling back into the preparation flask, we are doing it by using an inverted funnel. Properties of hydrochloric acid. Now, after forming hydrochloric acid by dissolving hydrogen chloride in water using an inverted funnel. Ruben, do you have a question? Ruben, do you have a question? Properties of hydrochloric acid. So like any other acid, hydrogen chloride, like sulfuric acid, it fully ionizes in solution. Siobhan, you stop that before I remove you. So like any other acid, we are saying hydrochloric acid has a sour taste. It turns blue litmus paper red, that one we are aware. It is fully ionized in aqueous solution, indicating that it is a strong acid. This is the equation for ionization of hydrochloric acid. Whenever I ask you a question, write an equation to show that hydrochloric acid is an acid. This is the ionic equation I want. Hydrochloric acid, which is formed when hydrogen chloride gas is dissolved in water, it ionizes in solution to form hydrogen ions plus chloride ions. And this is in line with the property of with the definition of an acid, which says that an acid is a substance which when dissolved in water produces hydrogen ions as the only positively charged ions. So it is in line with that. So we have hydrogen ions plus chloride ions. Another reaction which shows that another property of hydrochloric acid, these are chemical properties. Now, it liberates carbon dioxide with carbonates. So when you have any carbonate, like zinc carbonate, and you add hydrochloric acid, you form zinc chloride plus carbon dioxide plus water. This reaction can be used in preparation of salts to prepare zinc chloride, as you can see. Remember that. So the ionic equation, you have carbonate ions plus hydrogen ions from the acid, and the product is carbon dioxide plus water. It forms hydrogen with metals above hydrogen in the electrochemical series. Now this reaction can be used in preparation of hydrogen gas, remember, and it is also a property of acids, particularly hydrochloric acid. So we could have also used the zinc here. It is actually the one we always prefer to use, and we form zinc chloride plus hydrogen gas. It neutralizes, this is another chemical property, it neutralizes bases to form salts and water. You know, hydrochloric acid, like any other acid, when it is reacted with sodium hydroxide, which is a base, acids react with bases to form a salt and water. So you studied that in senior 2. Remember about acids and bases. So when sodium hydroxide is reacted with hydrochloric acid, the product is sodium chloride and water. So the ionic equation, you have hydrogen ions from the acid plus hydroxide ions from the base. Yeah? A base, you say it is a substance that produces hydroxide ions as the only negatively charged ions. So hydrogen ions from acid plus hydroxide ions from base will form water, and that is the property of hydrochloric acid. Then the other one, with bases neutralization, we have basic oxides. And the example, you remember basic oxides are oxides of metals. The best example we can use here is copper 2 oxide. So copper 2 oxide, when it reacts with hydrochloric acid, it will be changed to copper 2 chloride plus water. So this is a reaction between basic oxide and hydrochloric acid. Then the other chemical property, we are saying oxidizing agent, e.g. manganese 4 oxide and potassium permanganate, they oxidize the concentrated hydrochloric acid to chlorine. And this is what we have. Remember, we also talked about that. This is in the preparation of chlorine. Yes, this is in preparation of chlorine. So these properties are due to the fact that hydrogen chloride gas, although covalent compound, ionizes completely when dissolved in water, and therefore a typical characteristic of acids. So hydrogen chloride is formed by covalent bonding, but we are saying it still dissolves in water, which shows, and ionizes, which shows characteristics of what? Of acids. Let us look at uses of hydrochloric acid, and that's where we shall stop for our lesson today. It is used in the removal of rust from iron before it is galvanized. You remember, hydrochloric acid reacts with iron to form iron 2 chloride and hydrogen gas. So hydrochloric acid can be used to clean the iron before it can be galvanized, or to remove dust, to remove impurities or dust particles. It is used in cleaning of metals before they are electroplated. That is the same thing. It is used in manufacture of chlorides, of plastics, e.g. polyvinyl chloride. It is used in preparation of soluble chlorides. So those are the uses. But I wanted to find out something from you, such that we do it next time. Had you finished organic chemistry? I think no. You had not yet looked at,
Yes,
at that part of. I think you only stopped on alkenes. Is it correct?
yes,
Hmm?
yes.
Okay, that's what we shall be looking at when we finish hydrogen fluoride. Okay. Any question? So that is it for now. I'm organizing for you an assignment.